All right, an intro to functions. Functions should not be new. You've done functions before in your other math classes. So we're going to intro to them and talk about some of their properties today. All right, so we need to talk about a couple tests. There's some tests you need to be able to perform. All right. Yeah, no, not the Myers-Briggs test and that. But the first test we're going to do is a test called the VLT. Okay, who remembers what that stands for? Vertical line test. Yeah, veal, lettuce, and tomato sandwich. All right, vertical. All right, vertical line test. What does the vertical line test do, and what does it tell us? Go ahead, Daniel.
You gotta see if the points, like, or to see if it's a function, the points can't, like, go like this or whatever. They have to not be on top of one another.
Okay.
If you've got, like, a vertical line, it can't go through multiple points.
Okay, multiple points is the key. It can only go through, okay, you're going the wrong way. This way. Okay, not this way. Okay, we're doing the vertical line test. So, if a vertical line only intersects once, then the graph is a function. So it has to pass the vertical line test. So why? What about a function? Why, if something fails the vertical line test, would it not be a function? Go ahead, Dan, take a stab at it.
X in for multiple values and get the same answer. It's not.
It's the other way around. If you put X in, okay, and you get, right, two different Y values, is that what you said?
Yeah.
Okay. All right, if you put an X in, but you can get two different Y values, okay, it's like X has to be matched with one Y. You know, it's like a monogamous relationship here. So we can only have one X paired with one Y. And that's how we can tell if it's a function. All right, the other test you got to be able to do is the HLT, which is the horizontal line test. And that's going the other way. You have to pass them in order. If you don't pass the vertical line test, you can't even take the horizontal line test. You have to be able to pass the vertical line test first. All right, so if a graph passes both the VLT and the HLT, then we call it a 1, 2, 1 function. It's like the higher order of functions. Okay, it's the next level of functions. Okay, that means 1x for every y and 1y for every x. So it's both directions. For vertical, it's only 1y for every x. But in horizontal, it would be 1y for every x and 1x for every y. All right, now would you please grab out your graphing calculator, and would you please put the following function in. All right, into y1, would you please put x cubed minus 3x squared plus 4? What's wrong with that equation, the way it's set up? The y is in the wrong spot, okay? The y is not by itself. So what we need to do is we need to get y alone. What should I do on both sides?
Subtract
5.
Yeah.
Okay. then what should I do to both sides?
Square root.
Okay, you're still missing something. Didn't learn anything from your test yet?
Plus, I guess not.
What goes in front of every single square root? Plus or minus. Okay, you can't just throw a square root on there. Okay, when you include a square, just like with an absolute value, when there's an absolute value, it means plus minus. When there's a square root, it means plus minus. So you're going to have plus minus x minus 5. So now how do you put that in your calculator? Well, now we've got y2. And in y2, we're going to put x minus 5. And since there's no plus minus button in the calculator, we're going to have y3 to be negative x minus 5. So that's how you do plus minus on the calculator when there isn't a plus minus button. You have to separate them into two different y equals equations. So let's add those. Go ahead, you can unhighlight or clear out y1. We won't need that anymore. You'll have x plus 5, rad x plus 5, and negative rad x plus 5. Right. Okay. As soon as you get that done, flip over to your calculator. Clear out all the other stuff we were just looking at. All right, in your calculator, let's experiment with x to the third. All right, x to the third. It's an odd power. Does it have odd symmetry? Just because it has an odd power doesn't guarantee. You've got to take a look at it. So let's take a look at the graph. All right, does the graph go through the origin, first of all?
Yes.
Okay, now if I spun this graph 180 degrees, and so if I flipped it completely upside down, is there any noticeable difference between the version that's right side up and the version that's upside down? There shouldn't be. They should look exactly the same. It looks like quadrants 1 and 3, and you flip it over and it still looks like quadrants 1 and 3. So we would say this has odd symmetry. All right, now go back and now subtract an x. Now will that have odd symmetry? Okay, let's take a look at it. Okay, so now it's got a little bit of a bubble. It goes above quadrant, yeah, it goes above and then below. Does that have odd symmetry? Okay, well, again, picture it's kind of in quadrants 1 and 3, and if I flip it upside down, still perfectly in quadrants 1 and 3, so that would be considered odd symmetry. Let's try another one. Do x cubed minus 8x. Will that still have odd symmetry? And so you take a look at that graph. Now that quadrant is in all, or graph is in all 4 quadrants. Okay, it's going, looks like it's going up through quadrant 2 and then down through quadrant 4 and then back up again. But it does go through the origin. And then if I flip it upside down, it still has the same, so that still has odd symmetry. Okay, now try x cubed. Let's go back to x cubed minus x, and then let's throw a minus 2 on there. The first obvious problem with this is that it doesn't go through what? It doesn't go through the origin. And so it looks like it's crossing the y-axis at -2. And if you flip it upside down, now it looks like it's crossing the y-axis through +2. So this does not have odd symmetry, even though it has an odd power. Okay, the last example I want you to look at with me is 1 divided by x. Okay, 1 divided by x. Let's take, now that doesn't have any odd powers in it, but let's see what it looks like. Okay, 1 divided by x. Does it go through the origin? No.
Oh,
Okay.
what is that?
Okay, this is called a hyperbola.
I don't like that.
All right. It does not go to the origin, but could I still spin? What if I spin it upside down? Does it still have? Okay, so it doesn't have to go through the origin to be symmetric, but you spin it around the origin to see. So this would be an example of odd symmetry. All right, let's go back to your notes. So go back to your calculators and add a square on the x. Okay, go back to your calculator and add a square on the x. When you add a square on the x, now you get a graph that looks like this.
Whoa.
Okay, that is 2 equal parts. Okay, the graph is split right down the center of the y-axis into 2 equal parts. We say that's even symmetry. Okay, subtract a 3 onto that. Okay, subtract a 3. Does that graph now have even symmetry?
Yes.
Does the y-axis split it into 2 mirrored parts on either side?
Yes.
Okay, good. All right, let's clear that out. Let's try x squared. All right, everybody should know what x squared looks like. Does that have even symmetry? Okay, does the y-axis split it down the center? Okay, all right, now add a minus 3 to that. Does that graph have even symmetry? Does the y-axis still split it into 2 equal parts? Okay. Now try, instead of a minus 3 right there, try x minus 3 in parentheses and put the square at the end. Try that. Will that have even symmetry? So take a look at it. Okay, it's still a parabola, but does the y-axis split it down the center? No. So we say that that has no symmetry at all. All right, do you now have about 5 or 6 minutes to try the next section, and then we have 1/3 section of our notes. Okay, so the next section of your homework starts, I forget what number. Okay, we're going to talk about domain. This will be the part of your homework you'll have to do on your own. Okay, the domain of a function. You've talked about domain since middle school, probably in pre-algebra, algebra 1, and then again in algebra 2. I don't know if it ever sunk in for you what domain is, so we'll try one more time to help you understand domain. All right?
Oh, we're going straight to 1.6.
Oh, I'm sorry. Nope, I just wrote it wrong. It's 1.2b.
Oh, okay.
It's my fault. 1.2. You fix it. I'll fix it later. Okay. Think of domain as like a bouncer at a club, right? The bouncer at the club says, you can come in, you cannot. You can come in, yes, you, not you, not you. Okay? In functions, you are acting as the control person of who gets to come into the function and who does not get to come into the function. You have to meet certain requirements. And in order to get in, you have to make sure you're not going to break the first 2 commandments of math. All right, can anybody think of one? Something that somebody has told you, you cannot do this in math. That is the first commandment of math. Number 1, thou shalt not. Okay, thou shalt not ever divide by 0. All right, thou shalt not divide by 0. And to make sure that that doesn't happen, we're going to use the not equal to 0. Now, last chapter, we did all these, like, set it equal to 0, set it equal to 0. We're going to set it not equal to 0 because we do not want it to be equal to 0. All right. Can anybody else think of a second thou shalt not? Like something maybe, so like the first commandment, you try and do it on your calculator. What's your calculator going to say? Error, okay? It knows you're not supposed to do that. You can't divide by 0. All right, have you ever gotten error any other time on your calculator? You've tried to do something?
When I type words.
Okay, can you think of it? Here's the second one, just for sake of time. Thou shalt not square root what kind of number? You can square root 0. That's no problem. You cannot square root a negative number. You try it, again, you will get error. These are when your calculator knows the rules, okay? Calculator knows the commandments that you cannot square root a negative number. So what's the opposite of a negative number?
A positive number.
Is it really? Is that really the opposite of a negative number? Just a positive number? You've left out one number.
0.
You've left out 0, right? Okay, and so for that, we have to use the symbol greater than or equal to 0 to make sure we're not using a negative number. So these two commandments are what you have to look at when you're talking about domain. So let me give you some examples. The questions are like this. State the domain, which is basically saying you're the bouncer. Who can play in this function? Who can come in? Who are you going to let into this function? State the domain. And by the way, even if your homework says different instructions, my instructions on Canvas say, I want you to state the domain. That's all I want you to do for every single question. Even if the instructions in the book say something different, you state the domain. I wrote that in Canvas too, so just being clear. All right, state the domain. Example A. F of x equals the square root of x plus 3. This is a red flag to you because it has to do with two of our commandments. Right? It has a square root, and we have a commandment about square roots. So if you want to find domain, you take what's in the square root and you use the symbol that I just showed you for that commandment. So we're going to take x plus 3. We're going to take the symbol that goes with square roots, which is greater than or equal to 0. And then you do the math to both sides. And what do you get? X is greater than or equal to what? Negative 3. That is called the domain. So that means the bouncer at the door, if the club was this function, that the bouncer would only let in numbers that were greater than or equal to negative 3. So if negative 5 came to the door, what would the bouncer do? Okay, what if 0 came to the door? What would the bouncer do? Let him in. Because 0 is greater than or equal to negative 3. That is called domain. So it's just usually an inequality that you're going to submit. All right, example B. G of x. The square root of 5 minus x. Okay, well, the bouncer has some work to do for this problem. So you take what's in the square root, which is 5 minus x, you use the symbol associated with that commandment, which is greater than or equal to 0, and you solve the math problem. Daniel. So what do I do to both sides?
Add x.
Ooh, add x or subtract. I'm going to stick with subtracting 5. That's what I heard first. Okay, subtract 5, then what? Divide by negative 1, which means what do I have to remember? All right, and there's my rule for my domain. My domain is x less than or equal to 5. And so the bouncer at the door of this function would only let in numbers that were less than or equal to 5. So if 11 came to the door, they'd say, nope, not today. You're not coming into this one. Okay, what if 5.01 came to the door? Okay, please. I'm just 5.01. Like, nope. Okay, can't get in. I'm on the list. Okay, all right. C. H of x. The cube root of x plus 1. Okay, does the bouncer have any work to do with this?
He's like, you know what?
Okay.
Just retire.
It's a cube root. Are there any commandments about cube roots? So the bouncer can let anyone into this function that he wants. So when that happens, then we say that the domain is all real numbers. And the symbol for all real numbers is a scripted R. Usually has a double line on one side. And then the R, if you want to color that in and make it, some people will write it like that. That means all real numbers. That means there's no limitations. Okay, that means this bouncer can let any number into this function that wants to come in. There's no restrictions on that.
No age restriction.
All right, question D. P of x. Okay, P of x. 7 over x plus pi. Okay, does the bouncer have work to do here? Okay, is there a rule about division? Yes, there is a rule about division. There's a rule about square roots and there's a rule about division. There's not a rule about cube roots. There's a rule about division. The rule about division is not equal to 0. And so you have to take the division part of the problem, which is x plus pi, and you set it not equal to 0. So that's the symbol that you use for that rule. What do I do to both sides?
Oh, okay.
What do I do to both sides? I'm just trying to get x by itself. Subtract pi. So x is not equal to negative pi. And so the bouncer will it let positive pi in? Sure. Okay, the only number that cannot come into this function is negative pi.
So as the answer, you would just...
This is the answer.
Okay.
Yep, because we're just listing what the domain is. Okay, Q of x. All right, Q of x. Square root of x over x plus 4. Does the bouncer have any work to do on this question? The bouncer's got to worry about 2 rules. The bouncer has to worry about the rule for division, and the bouncer has to worry about the rule for square roots. So we're going to use both symbols. We're going to use greater than or equal to 0. We're also going to use not equal to 0. So which part of it needs to be on the greater than or equal to 1? Which part of that is controlled by that rule? The numerator, right? Just the x, just what's in the square root. And which part of it goes with the not equal to 0 part? What's in the division, which is x plus 4. So you have to do both of these things. Now x greater than the 0 is already done because x is by itself. The x plus 4 part I have to subtract 4, so x is not equal to negative 4. So the bouncer has 2 rules, 2 lists to check if when people come. All right, you come to the door. I want to get in. Okay, well, you're 3. Yep, you're okay. I can let you in. Okay, you're negative 5. Sorry, can't let you in. Okay. All right, how about this one? R of x. 1/2 x squared plus x to the 5th. Does the bouncer have any rules to be concerned about for this function? Okay, does he have to worry about division? There's no division in this problem. This is addition. This is no division. Does it have to worry about square roots? No, there are no square roots in this problem. Is there a square? Yes, but it doesn't matter. Only square roots. And so what will the bouncer say for the domain of this problem? All real numbers is the domain. Yeah, Daniel. You can square 0. You can square root 0.
Oh, yeah.
You just can't, you can square root anything. You can square root all the way down to 0. You just can't square root anything that's less than 0. All right, last one. Oops. All right, example G. T of x is the function 12 divided by x squared plus 2x minus 3. All right, last call. Does our bouncer for the domain have to worry about anything here? Yes. Why? What rule does he have to be concerned about? The not equal to 0 rule. So what is not equal to 0. It's the part of the division, the denominator, x squared plus 2x minus 3. How do I solve that? I can't just move the 3 to the other side like I did with the other ones. What do? I have to factor. Ryan's on it today. Okay, you have to factor. All right, you can't just move the 3 to the other side and work because there's a square, which means this is a factor problem. So we would go back to our star method and we would figure it out. Let's imagine we've already done all that. And we end up with x plus 3, x minus 1. What do we do with both of those? Last chapter we set them equal to 0. What do you think we have to do now? Not equal to 0. So x plus 3 not equal to 0. X minus 1 not equal to 0. So x cannot be equal to negative 3. X cannot be equal to 1. And so my bouncer has 2 numbers he's on the lookout for. All the other numbers are allowed to come into the function, but this bouncer cannot let in negative 3, and he cannot let in 1. I'm sorry, I cannot let you in. And that is called domain. So think about what rules math has, and then work accordingly with the symbols not equal to or greater than or equal to.